In this video, I'd like to introduce you to a non-traditional strategy for finding the greatest common divisor of two numbers, known as Euclidean algorithm. Euclidean algorithm is found in Book 4 of Euclid's Elements, 300 BC, but is seldom taught. First, we're going to divide the larger number by the smaller number. Then we're going to ask the question, is the remainder 0? If the answer is yes, divisor is greatest common divisor of original numbers. If no, then we're going to divide last divisor by the remainder. Then we're going to go back and ask the question again, is the remainder 0? If yes, divisor GCD. If no, divide last divisor by the remainder. And we continue until it divides out with no remainder. Example 1. Greatest common divisor of 2665. So we're going to take 26 into 65. 26 goes into 65 two times with 13 left. So this remainder is not 0. So we take 13 divided into the previous divisor, which was 26. So we take 13 into 26. 13 goes into 26 two times, which is 26. We have a remainder of 0. Since we have a remainder of 0, 13 becomes your GCD. Example 2. GCD of 24 and 90. Take 24 into 90. 24 goes into 90 three times, which is 72. We have 18 left. It's not 0, so we take 18 divided into the previous divisor, which was 24. 18 into 24 is one time, with 6 left. We still do not have a 0 remainder. So now we take 6 into the previous divisor, which was 18. 6 goes into 18 three times with 0 left. Now we have a remainder of 0. So we go back. 6 becomes your greatest common divisor of 24 and 90. What if we had 3 numbers we wanted to find the greatest common divisor for? Well, in this case, we have to go through the process twice. We take the first 2 numbers, let's say 150 and 220. Take 150 into 220 one time with 70 left. Not 0. Take 70 into 150. Goes 2 times. 10 left. We're still not to a remainder of 0. Take 10 into 70. Goes 7 times, which is 70. 0 left. So 10 becomes the greatest common divisor of 150 and 220. So now we take this 10 and divide it into the other number, 400. So 10 into 400, if we look at this, we can tell that 10 goes into 400 evenly 40 times. Okay? So then 10 becomes the greatest common divisor of all 3. Where can we use this strategy? Simplifying fractions. Example 1, simplify 55 over 85. First, can you simplify this fraction? Second, where would you start? Third, how about Euclidean algorithm? Fourth, divide smaller number into larger number to find GCD. So we take 51 into 85, one time, 34 left. Now we take 34 into 51, the previous divisor, one time, 17 left. Still not 0. Take 17 into previous divisor, 34, 17 goes into 34 two times, which is 34, so we have 0 remainder. So 17 becomes your common divisor, greatest common divisor. So now divide numerator and denominator by 17. So 17 into 51 would be 3, and 17 into 85 would be 5. So 51 85ths simplifies to 3/5. Would you have been able to see that without Euclidean algorithm? Some would not. Let's look at example 2. What about 52 65ths? Can you simplify this fraction? Where would you start? How about Euclidean algorithm? Divide smaller number into larger number to find greatest common divisor. 52 into 65, one time, 13 left. Now we take 13 into 52, 4 times, which is 52, 0 left. Now we know that 13 is the greatest common divisor. Divide numerator and denominator by 13. 13 into 52 is 4, 13 into 65 is 5. So this simplifies to 4/5. This is where we can use Euclidean algorithm to help us whenever we have those extreme fractions we want to simplify. I would like to thank you for taking the time to watch this video. Hopefully you found it informative and beneficial in your future endeavors of math.